All right, today we're going to be covering what you need to know about operator safety and breathing respirators for sandblasting, and if you're using a force-fed hood for painting, what you should be considering and what you need to make sure you're aware of so that you're safe as a painter or sandblaster, and so that you can ensure that you are not exposed to anything that could be potentially harmful. So OSHA standard 1934 subsection 1 lays out the requirements for the air that's used for a supplied air respirator. That includes blast hoods like you see here for sandblasting, as well as force-fed hoods for painting. And what they're typically referring to in that standard is what they call grade D breathing air. Some of the characteristics of grade D breathing air is that it's free from oil to a certain extent, and it's a very small amount of any oil that could be potentially in that line, as well as water volume or content in the air, and finally also the carbon monoxide content that's in the air that comes to you in your hood. All these are issues that come with any oil lubricated compressor. So you really have two ways that you can be safe when using a supplied air respirator. One requires that you properly eliminate and monitor the air being supplied to your respirator, and that's applicable if you're using an oil lubricated compressor. And the other one is to use a compressor that isn't dependent on oil for its functioning, and so as a result you can be sure that that compressor will not deliver any harmful contaminants inside the breathing air line, as well as won't be exposing you to carbon monoxide, assuming that it's being used properly. So what we're looking at in front of us here is what you typically would need to consider to use a compressed air line. So if you're using a tow behind compressor or even an electric shop compressor, these are some of the things that you want to consider to ensure that the air that your operator is being fed in their supplied air hood is safe for them to use. So first is removing water and oil contaminant as well as odor. And that's where an airline filter like you see here comes into place. This is a Clemco airline filter. You can get these for one operator or multiple operators. So if you need to feed a couple of sandblasters or a blaster and a painter into two different areas, you could use a system like this with one or multiple outlets to supply each operator to ensure that the air is free from water and oil and those sort of contaminants. Now, in addition to filtering out contaminants, you also have to worry about carbon monoxide. Carbon monoxide is odorless and it's tasteless, and with exposure you can develop headaches, you can suffer unconsciousness, which in any given situation can lead to harm or death, and there has been those issues that have occurred in industry over time. So to deal with carbon monoxide, there's really two ways you can. One is to use a high temperature alarm, and what OSHA sets out in the standard is that you would conduct frequent sampling of your compressed air to ensure that there's no carbon monoxide present in the air. The problem with that route is there's not a set policy or a set way that they set aside to know how often and the frequency of sampling. So what they're really leaving a lot of room there for potential issues, and in general is not an ideal route. Ideally, we want to monitor for carbon monoxide so that even if you are properly sampling, say there's a truck that parks next to your compressor source and you feed the exhaust from that compressor from the truck into the compressor, that will be fed to you as an operator, and there could be carbon monoxide in there. So for both safety and for ensuring ease of compliance with regulation, it's a better situation or recommendation to use a way to monitor for carbon monoxide within your breathing air system. There's really two ways that that's done typically. One's going to be an external monitor that would be placed near the operator with an audible alarm, and there's kind of two designs to that system. One of those being just a suitcase that will mount next to a blast room, the other being similar but would also just be in the field, and I can show you that here. They do come, these units often come with a remote alarm option, as you can see, that will enable you to place the actual sounding alarm closer to your blast area, so if you have the monitor down away from the operator, he can still hear and be safe. Some of the problems with this route potentially are that you have to be aware of the monitor's location and ensure that somebody's constantly monitoring to hear if it's going off. Now your other option, which is a little bit newer to market, this is called a CMS3. This is a Clemco product. Inside of their blast hoods, they actually maintain a NIOSH and OSHA certification with this monitor in it. That hasn't been tested and certified with other blast hood manufacturers, but this unit still does monitor for CO. The way it works, it's a hood mounted design, so it would go inside the hood up in the corner here, and the unit allows you, and it will test the air inside the hood for carbon monoxide. So if you get too high of an amount of CO, the monitor will go off. The operator would then know it's time to get out of the hood, get out of the work area, verify what's causing the issue, and ensure they're safe. The unit is for the unit and the test gas, which you need to continue to calibrate the unit, as best practice is to calibrate this unit before most work days so that you ensure that it's properly determining CO concentration or carbon monoxide concentration. You can get the unit with the test gas for around $760, and then that allows you as an operator to not have anyone dedicated to maintaining or visualizing that your alarm is not going off, and it can give you comfort if you're a job operator in charge of blasters that they know if there's an issue at hand. So this is a great option. Comparatively to the suitcase monitors, this is a little bit lower cost. Suitcase style monitors are north of $1,000 for those type of units, and this tends to be a little easier. It's battery operated. The calibration kit comes as you see here. We'll briefly show you how the unit functions. You can calibrate pretty easily. Calibration gas connects to the unit, and then you can open up that gas. I'm going to show you what it looks like when it's alarming so you get an understanding of that. I'll turn it on. You see it just turns on as you would expect. So now at this point we're monitoring for CO, and I'm going to turn on the gas to simulate a false positive here. So at 10 parts per million, which is the OSHA requirement for compressed CO, maximum amount of CO present in breathing air, this unit will alarm, notifying the operator, and then they would leave the issue area to figure out the source. Now, you notice when I'm taking it off, it's counting down to 0 because there's no more issue, and you can turn off the alarm and it's good to go. Unit's calibrated easily, a couple button pushes, but it's very flexible, very friendly, and overall is a great way to ensure safety for your breathing air for sandblasting. For a paint hood, this wouldn't work, but you could also use what we call free air pump, and we'll show you that shortly.